Okay, so I'm gonna do the Regents exam from January 2025. Subatomic particles in the nucleus. That's gonna be protons and neutrons. Protons for the charge, neutrons have extra mass and they have no charge. The electrons are always found around the nucleus, so you know that it's not 1 or 4. And then if it were only neutrons, that doesn't really work because the number of protons is what gives us an idea about the identity of the element. Like, say for hydrogen it has 1 proton, sodium has 11, and so on. Charges, protons, neutrons. They have opposite charges because protons are positive, electrons are negative. And in an atom, they are equal in number because unequal would mean that this is an ion. Most probable location of electrons. So that would be the electron orbitals. Like this is S orbital, P orbital. And all you really have to know for this is that it's around the nucleus and it's where you're most likely to find an electron. C12, C13 isotopes because same number of protons and different number of neutrons. If they had the same number, they wouldn't be different, right? So we can cross the first two out. And since it's still the same element, carbon, it wouldn't make sense for it to have a different number of electron shells. So we can determine that the answer is 3. Differentiate between STP, which property can be used to different. So this is at standard temperature and pressure, so we're not going to be able to differentiate based on temperature because at STP they're both 0 degrees Celsius. So we can cross this one out. And then the phases here, this letter tells you about the phase, and that we can see here that they're both gases. So we can cross number 4 out too. And since they're both 2 grams, it's not mass, so it's 3. And you can also just tell because helium is a noble gas, and noble gases are not very reactive, so it most likely will not react with sodium. So that's like a chemical property of noble gases. Sorry. Molecular structure and properties. Okay, so I feel like this is definitely not the first time they've put this question on here. So one has 2 oxygens and the other has 3. So I think that it should be pretty straightforward so that you can know they have not the same properties and they have different structures because one would have 2 and the other would have 3. And if you have a different structure, you're most likely to have different properties. Like if you think about graphite and diamonds are both carbon, but they're arranged in a different structure, so there's that. And then broken down by chemical means. So this one is Al, aluminum, argon is Ar, arsenic is As, ammonia is NH3. So you can see that this is a compound, so this is the only one that can be broken down because the other ones are all elements. Zinc is a metal, so you can pretty easily determine that it has metallic bonding. For in order for it to be covalent or ionic, it would have to be a compound. This one is between two nonmetals. Metal and a nonmetal. So you can cross these out. And hydrogen bonding is a type of intermolecular force that exists between either HO, HN, or HF. So we can tell that zinc is none of these. So we can also cross number 2 out. And then 9 asks about polarity, a nonpolar molecule. So it would be symmetrical distribution of charge. So number 1, we have CH4, so methane. The hydrogens are slightly partial positive here, so we can draw these. And if you draw lines of symmetry, you can tell that this does have a symmetrical distribution of charge. So this would be a nonpolar molecule. Okay, so here we see 1 fluorine, 2 fluorines being combined into 1 diatomic fluorine. So this is forming bonds, because there's one thing and there's a second thing, and they're forming together to make fluorine gas. And then the acronym break, absorb, release, form. So energy is released as a bond is formed. Based on table S, has the greatest attraction for electrons in a chemical bond. So generally, since these two are metals, you can pretty much cross them out right away. And then this is just like electronegativity type questions. So according to table S, oxygen is 3.4 and sulfur is 2.6. So the oxygen here would have higher electronegativity, which means that it is able to attract more electrons. Solution is made by completely dissolving. Solution is classified as homogeneous mixture. So since you're dissolving sodium hydrogen bicarbonate in water, this would be in an HCO3 AQ. So being a combination of sodium hydrogen carbonate and H2O, this is definitely not a compound. And then since we're completely dissolving it in water, and this is soluble too, it would be a homogeneous mixture because we wouldn't be able to see precipitates form. If we have precipitates, it'd be heterogeneous, but we don't have that, so that's not really a concern. In which sample of matter can proportion of its components be varied? Okay, so the only one here that can be varied is the aqueous potassium bromide. You can have more water, so that would be a dilute solution. Or you can have less water and have it be a more concentrated solution. All the other ones, if you're changing the proportion, you're changing you're changing the thing itself. So for example, for this one, if you have let's say 2 potassiums, that's not going to work. So it's definitely not this. And then these two are their elemental forms. Like atomic chlorine is chlorine gas, and bromine is just liquid bromine. So you also can't change the proportions of those two. Ideal gas. Okay. So, according to kinetic molecular theory, they definitely don't have attractive forces between them, because if you think about it, an ideal gas, they're not losing energy between collisions. They're traveling in a straight random line motion. And they're very small compared to the distance that separates them. They're completely, the collision transfers energy, and so increase would be inaccurate. This one, kinetic molecular theory, is something that you just kind of have to know, and it's pretty okay. It's very useful. Chemical reaction collide with proper energy and proper orientation. Like, I saw a good analogy one time. The person said that just think about when you're at an amusement park and on those little car thingies, you want to try to drive your car towards other people, right? Because that makes you kind of move into the other way, like get bounced off and then go in the opposite direction. So, yeah. That's that. So, at STP, same number of molecules as 22 liters. This one would just be number 2, because always at STP, 22.4 liters is 1 mole of gas, right? So, same number of molecules equals same number of moles. So this wouldn't be right, this is not right, and this is not right either. Because this would be 1 mole, 3 moles, ish, approximately, and 4 moles. Based on table I, which chemical changes exothermic? So for this one, you would just look for the one that has energy or heat as a product. Oh, there's a key on the bottom. It says a minus sign indicates an exothermic reaction. So exothermic reactions release energy. So it would have a negative delta H heat as a product, because the reaction produces heat, which is releasing energy. And so for that, for this one, the delta H is minus 84, and for all the others, they are positive. So for example, the first one, it has a delta H of positive 66.4. So that would be an endo. And yeah. Identifies factor affects the rate of a chemical reaction. So for this one, wow, these really are pretty irrelevant. They're all nuclear chem and they don't really affect the rate. So factors that affect the rate: surface area, temperature, and also something that affects the rate of chemical reaction would be a catalyst. There was something else, but I forgot. Can't think of it right now off the top of my head. 4. Oh, concentration. Like the amount of reactants. net amount of energy released or absorbed. Okay, so let's read through these. The kinetic energy of the reactants plus the potential energy of the products. That doesn't really make sense, right? So we're comparing kinetic energy to potential energy. So what this is talking about is when you have like a potential energy diagram, and then the bottom says reaction as reaction proceeds. Like this would be your typical exothermic reaction. So your delta H would be products, reactants. Delta H equals products minus reactants. So it would be the potential energy of products minus the potential energy of reactants. Because this just doesn't make sense. The net amount of energy released or absorbed would be like the difference and not the sum. So, yeah. Oh, we were just talking about catalysts. Catalyst increases the rate of chemical reaction by providing an alternate reaction pathway that has a lower activation energy. Because, like, this is our potential energy diagram again. For example, this might be your original reaction pathway. And then this would be with the catalyst. So you see there's the energy barrier is much smaller for a catalyzed reaction. So therefore, it would increase the rate of reaction. It would make this reaction happen quicker because the threshold, the reactant particles, the threshold is lowered basically because the reactant particles don't need as much energy as they typically would, having to climb over this versus this. Like, would you rather jump over a block that's this high or a block that's this high, right? So yeah, systems in nature tend to change to lower energy and higher entropy. So disorder is entropy, and you can think of this concept as essentially chaos. Like, the most common analogy I hear my teachers use is the room. And whenever you clean your room, it's sparkly clean. And then after a few days, there's shirts on the floor, there's papers all over my desk, and it's just very chaotic. And then systems in nature tend to lower energy because if you think about it, which reaction do you think would be more spontaneous? Probably this one, right? Because look how small this energy barrier is compared to this one. So a lower amount of energy here, easier. Okay, chains, rings, and networks. This one's carbon. There's an orgo unit in Regents Chem, so you should be pretty familiar with this concept and this special property of carbon. Functional group table R, and you would see that this one would be an alcohol. You can also like just memorize it, I guess, to not have to look at table R, but that's up to you. Which statement explains why butane and methylpropane are isomers of each other? Okay, so to be isomers means that they have the same composition. Like they have the same number of different atoms making up their chemical structure. But They're isomers because they have a different shape or functional group. So here they would have the same molecular formula, but not the same structure. So this one would be our right answer. Which contain multiple covalent bond? Okay, so this one is a saturated hydrocarbon. Does not have multiple covalent bond. So we can cross that out. So we're only left with number 2. Very straightforward. Types of organic reactions. Deposition is when, say you have like something insoluble, and then you add water. It's still gonna precipitate, right? So there's that. And then this one is when you have something turning into a solid. This one is when you have liquid going into gas. So this one would be the only one that makes sense. Like substitution, you would have something like this, where you have, I don't know, say you have this thing. And then that goes to like that. That's substitution, because one of these is substituting in, and you can see the difference. Statement, oxidation, reduction. This is not true. So have our very useful mnemonic. Reduction happens at the cathode, oxidation happens at the anode. This one. Yields salt and water. So this one would be a neutralization reaction, because when you have any acid or base, let's just say HCl and KOH, they will make H2O and KCl, which is a salt. Because this is an ionic compound, right? A salt doesn't have to necessarily be not necessarily an ACl. Any ionic compound is salt. So yeah. Heavy nuclei split into lighter nuclei. So this one would be this one, because, okay, first of all, these two are not nuclear reactions. Not nuclear. And then this one is when two smaller things make a bigger thing, because they fuse together. But this one, they fizz. So think about bigger thing fizzing into a smaller thing. Large amount of heat. Because nuclear reactions are funky, okay? They make mass into energy. Are funky. Mass into energy. You just have to remember this special thing about nuclear chem. They basically break all the rules. So there's that. What is the approximate mass? So electrons are essentially massless. as far as we're concerned. I think the mass is like 9.1 times 10 to the negative 31 kilograms or something. So we can pretty much ignore this and pretend that it's not here. So we just add these two together and we would get 25. Bright line spectra. So right off the bat, we can see that it's not B, because there's no double line here that's missing. And then, oh wait, it says which contains, oh my gosh, I did not read. I was like, wait a minute. Okay, so we can just line this up and see that it's actually B. It's actually B? Oh man, that's kind of embarrassing. So it's actually B. So bright line spectra is something that you get when you blast energy at something, and then the electrons get excited, and then they go to a higher energy level, but then when they return, they emit this photon, and they have this unique bright line spectra that is like unique to that element. So this is what you have here. Oh, this big back is too big. So this is what you have going on here. What is the valence electrons? So valence is outermost. So this one we can see right here that it's just 3. Always scroll too far. General trends, electronegativity, atomic radius, increasing atomic number. So here we have period 3 going this way. So as we go right, atomic radius decreases, right? Or because all the protons, there's more protons, which means that there's a stronger force of attraction because we have a bigger nucleus, right? So that's going to pull the electron shells in tighter. So we can cross out the ones that say the radius increases. And then electronegativity will also increase because, like we said, there's more protons, which makes the nucleus bigger, and that makes the element more able to attract the electrons from other elements. Chemical name for KClO2. So this is a polyatomic ion from table E. This is called hypochlorite. Like, just that part itself is called. Ooh, messed this up again. Okay, so chemical name for KClO2. ClO2. This is in table E. This is chlorite, so we can just ignore the other ones. This would be ClO3, ClO, and the next one is ClO4. So yeah, this one has 2, so it's chlorite. And then percent by mass of oxygen. Okay, so you need to take these out. 16 times 2 divided by 60. Get that the answer is 53%. Oh, you have to times 100, but 53%. And then how many electrons are shared between the carbon atom and the oxygen atom in the molecule of this compound? So we see 2 bonds, or I mean a double bond. So one bond, like one line like this, equals 2 electrons. So we have 2 bonds. We have 2 times 2 equals 4 electrons. So that would be your answer here. Neon at STP. So neon, we know that, well, it's probably good to know that neon is a gas at STP. So you wouldn't have this. And also neon is monoatomic, so you wouldn't have stuff like this. So it would be 1. the mass, how many significant figures? Okay, so this is its mass. We can count 1, 2, 3, 4. 4 significant figures. The zeros count because of the decimal. So yeah, you have 4 significant figures. Energy transfer. So energy always from where it's hot to where it's not. So the copper is hot and the water is not. So it goes from copper to water. These two just they just don't make sense. And then, oh, that's my dog. Come here. Which change will cause an open flask half filled with water to reach phase equilibrium? Okay, so in order for something to reach equilibrium, you have to make sure that it's in a closed container. So yeah, we should just seal the flask with a stopper so that you have something like this going on where you don't have things escaping, right? Because if you always had things leaving the container, the vessel, you would never reach equilibrium. Open vessel. Amount of heat released. Yeah, so that we see this reaction here is N2 plus 3H2 is 2NH3, and that releases 91.8 kilojoules of energy. But since we're only making 1 mole, we have to half this amount. So if we half that, it's 45.9. Given the equation representing a phase change for carbon dioxide in terms of energy and entropy. So since energy was a reactant, it was absorbed. Like, this had to absorb energy in order for the reaction to happen. So this would be what we call an endothermic reaction, because exo heat leaves or exits. I can't spell today. And the endo is the opposite, absorbed. And then since we're going from solid to gas, we're increasing in entropy. Because if you look at a sample of solid, you would see that they're tightly packed, very uniform. They have a set shape. But if you look at a sample of gases, they're going everywhere all at once. So that's very random. So yeah, endothermic and increasing entropy. Oxidation is lose electrons. So which one shows losing electrons? Well, it would be both of these actually, except this one doesn't make sense because this is what happens when you, like this change here, gain 2 electrons, and then you would have that. So that one is also not right, even though it represents a loss of electrons. So this one would be the only one that's right. Because if you look here, there's an increase in oxidation number, indicating loss of electrons. So since electrons are negative, losing them would make you more positive. So that's what happened there. Redox reaction is just a change of oxidation numbers. So we can just look here. Okay, let's start with the first one. So this is both of these are elemental, carbon and oxygen, but together this is -2, and +4. So the carbon was oxidized here, and the oxygen was reduced. So this first one would actually be the redox reaction. Spontaneously with copper ions. Okay, so what we have to do here is just look for an element that's higher than Fe activity series, which is table J. And we can see that the only one that's higher than Fe that's on here is magnesium. These three are like the lowest ones. The three lowest ones. This being lowest, second, and third. So that's pretty funny. Based on table F, saturated solution, best conductor. Okay, so we want to see which one dissociates into the most number of ions. Most ions. Because more ions, better conductor. But before we get there, this is not soluble. This is not very soluble. And I'm pretty sure this one is also not soluble. Wow, so they gave us 3 insoluble. That's pretty okay. That was simpler than I thought. Okay, well, since this is the only one gives Na and NO3 ions, this one is the best conductor because none of the other ones are very soluble, meaning that they'll just stay in one piece and be precipitates. So yeah, there's that. Acid-base theory. Okay, so first of all, we should just go through all of them, I guess. So these two are a pair, these two are a pair. It says HSO3 acts as an acid because it's the H plus donor. That's true. Acts as an acid because, no, that's not true. Remember, bases accept, acids donate. So that's not, the second statement is not true. And then H2O in here acts as a base, actually, so these are not true. Because this one, since it has the additional H, this would act, the hydronium would act as the acid in this case, the conjugate acid of water. So the first statement is true. What is the pH aqueous solution? 1,000 times greater. So 1,000 times greater means that it is -3 on the pH scale, because increased hydronium means lower pH. It's more acidic, right? Because the hydronium, remember the hydronium is the acidic, and the OH hydroxide is the basic. And if you go high on the pH scale, it's basic, and if you go low, it's acidic. So having a high concentration of hydronium ions would mean that we're decreasing on the pH scale. And since we're 1,000 times equals 1.0 times 10 to the third, we're going to be -3 on the pH scale. So we will go 2. Which energy source is paired with risk associated with usage? Oh. So not these two. We use batteries all the time. And also, since when did they produce radioactive waste? Hello? And then, okay. So risk. This is not a risk. The only answer will be this one, because nuclear power plants produce a lot of nuclear wastewater, and that's actually a pretty big concern for a lot of different countries using nuclear power even today. So that's an issue. Okay, FRQ section, yay! How light emitted by, okay. Wait, I think I talked about this earlier. This is so fun. Okay, so, light emitted by one electron returns to lower energy level from excited state. Light is emitted. This is how I would answer it. You can phrase it more fancy if you want to, but I don't think you have to do that. And then atomic mass. Wow, they ask this every single year. This is pretty insane. So this is just the atomic mass times its percent abundance in decimal. And then you add the two isotopes. And it's only a numerical setup, so you don't have to get a value for this. Okay, now we have to do the actual math. Where's my calculator? My chair's so creaky. It's been creaking this whole time. Okay, so here I got 63.547, and the percent error formula is measured minus accepted over accepted. So measured here oh shoot, that's not what they meant. Okay, it's only for this one. I thought it meant for all the atomic masses together. Okay, sorry. So you didn't have to do this step. You can ignore that. Okay. Okay, so we still use the same formula though. I'm gonna round that up. 0, 1. So there's that. Based on location of group 2 elements, state the element classification. So if you look at group 2, all of the elements on group 2 are metals. You can also say alkali earth metals. So, yep. It's pretty straightforward. In terms of electron shells, why atomic radius of calcium atom is greater than the magnesium atom. Okay, so if we look on the periodic table here, magnesium has only 3 electron shells, while calcium has 4. So the additional electron shell makes calcium have a greater atomic radius than magnesium. So you can say magnesium only has 3 electron shells, while calcium has 4. The difference makes calcium a bigger atom. State the general trend in first ionization energy, beryllium through barium. So the first ionization energy should be decreasing. I'm lazy, so I just wrote IE, but you should write first ionization energy out completely on your Regents exam. The reason for this is going down, we're gaining more and more electron shells. So the distance between the nucleus and your valence shell is increasing, which means a decrease in the force of attraction. Therefore, it becomes easier and easier for other electronegative elements to take away the electrons from the elements that are further down group 2. So, yep. I don't know if I should go on a side tangent about Faraday's law, but it's pretty interesting. Let me know if I should. 57. So the average kinetic energy. Oh, they're both at 300 Kelvin, so they're the same. Because average kinetic energy basically just means temperature. And since they're both at 300 Kelvin, they're the same. Determine the volume O2 when conditions are changed to STP. Okay, so this one we would use the combined gas law. I'll probably just keep that at 0.97. Pressure in atmospheres of nitrogen in diagram 1. Okay. So we're starting at 60 kilopascals. And 101.3 kilopascals is 1 atmosphere. So you just divide that, which would give you 0.59230. You can round. I don't really think they'll mind, but be sure to include units because they'll definitely care about that. Compare the potential energy of molecules in the sample before vaporization and after vaporization. So, vaporization is when liquid turns into gas, right? Because it's vapor. Just think about like water vapor. It's liquid going to gas. So, do gases have more potential energy or liquids? Gases do, right? Gases have so much potential energy. They have the most potential energy out of any phase. They're zooming around all over the place. While liquids, they have more than solids, but they don't have as much as gases do. Gases are just going everywhere, while liquids are just in their little container. So, you would say that potential energy increases after vaporization, or potential energy is greater. Just write the whole thing out. I think is pretty safe. Don't be like me and just write like these short little things. Yeah. Determine the amount of heat required to completely melt. Okay. So this is the This is Q equals M times heat of fusion. So Q equals 50 grams times 27 joules. And the answer you get will be 6,350 joules. Explain in terms of intermolecular forces why it's lower than the boiling point of water at standard pressure. So when something has a lower boiling point, it just means that the intermolecular forces of that thing is easier to overcome. So water being both polar and having hydrogen bonding has pretty strong IFAs. This means that the attraction between water particles are pretty strong. And what happens when you boil water, you're putting energy into the sample so that it can evaporate. So here's this. Because like even when you're just boiling water for tea or to make pasta or something, you're putting it on a stovetop or putting it in a kettle. So it's giving the liquid water energy to overcome its intermolecular forces and enter gaseous phase. So a compound that has low boiling point means that it has low or weak IFAs, because its weak IFAs are easier to overcome, making its boiling point a lot lower. So yeah, positive ion H+. Based on table M, litmus when placed in HCl. So litmus is red in acidic solutions, red in acid, and since HCl is an acid, litmus would be red. Using titration data, determine the concentration. Okay, so this one would be the MAVA equals MBBB. So we have 15 mil with unknown molarity equals 30 mil times 0.01 molar. So all we have to do is divide the whole thing by 15, and we can find that let me just type into my calculator real quick. Molarity is 0.02. Types of bonding used to make plaster casts. So we have that. This one would be both ionic and covalent. This is because when Ca is bonded to our polyatomic ion, this is our polyatomic ion sulfate. This is ionic. Because sulfate is -2, Ca is +2, so go together. And then between within the sulfate ion, there is a covalent bonding. Because sulfur and oxygen are both non-metals. So you would have ionic and covalent. Identify noble gas, same electron configuration as a positive ion. Okay, so the positive ion in Mg, so that's just the magnesium. And if we look on our periodic table, magnesium as a positive ion is Mg2+, which would have the same configuration as neon, Ne. Based on table S, determine the electronegativity difference for the bond between zinc and oxygen in ZnO. So let's just look real quick. So oxygen is 3.4, zinc is 1.7, 3.4 minus 1.7 is 1.7. This would be your answer. Compare the freezing point of water at standard pressure to the freezing point of a solution at standard pressure. Okay, so the solution would have a lower freezing point because KNO3 is soluble, so it breaks into ions. And when there are ions in water, the forces of attraction makes it harder for water to freeze, like colligative properties. So they make it so that the water, it's more difficult for the water to freeze, which makes the freezing point lower. Like, if you're watching this video, you probably are studying for the Regents exam in New York. And here in upstate New York, we have salt on the roads every winter. The reason they do that is because they want the water to freeze less easily, like the snow and the ice to not freeze. So that's why they put salt on the roads in winter. Then classify saturation. Okay, so 0.1 moles. 1 mole is 101. So it's 10.1 grams in 100 grams H2O at 25 degrees Celsius. Let's see what this is on our table G. It's always hard to read though, it's kind of annoying. At 25, you can see that it's about 40-ish. So this was definitely an unsaturated solution. Describe a laboratory procedure to separate. Okay, so you can either allow water to evaporate or just boil it so that evaporation happens faster. Since this is fully soluble, you can't filter. So the only thing you can do would be to distill, which is to boil that thing. And then reactants, synthesis reaction. Okay, so the reaction in here, this is a synthesis reaction because we have two compounds, ammonium and nitric acid, forming ammonium nitrate. So when we have two smaller things forming a bigger thing, that's evidence of a synthesis reaction. And you can pretty much word this one however you want to, as long as you're saying like two smaller ones are coming together to form something bigger. Label axes in your answer booklet, draw potential represented by. Okay, so as we can see here, energy is a product. Remember what we did earlier in the video? That means that this is an exothermic reaction. I'm pretty sure the answer booklet would probably just have something like this, and then reaction. So what I would do is just like make sure they know that this product is lower than reactants. RP. And then in the equilibrium system, so at equilibrium, rate of forward reaction equals the rate of reverse reaction. So you would just say equal or same, or I don't know how else you can say this. Say the number of hydrogen atoms in a molecule of hexane. So for this one, you can either count or you can work smarter by using table Q. Since this is an alkane, you can use the CnH2n plus 2. 2 times 6 plus 2 is 14, so you would say 14. Or you can count 1, 2, 3, 4, 5, 6, 7. My dog is playing with her tail. 8, 9, 10, 11, 12. Wait. This is pentane, so you can't count. I guess you can draw. Oops. I guess you can draw it out. But that just kind of takes time. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there's that. Why this is a saturated hydrocarbon. So you can say that all carbon bonds are single bonds. No double or triple bonds. You should write all these out, by the way. Don't do the shortcuts like I do. I do too many of those. Draw a structural formula for a straight chain molecule of heptane. So hept for 7. 1, 2, 3, 4, 6, 7. And then what do you want? Are you hungry again? State in terms of energy why the power source is required for the cell to operate. Okay, so this is just an electrolytic cell. Is that all you say? I guess so. Okay, so oh my gosh, I'm really having trouble with spelling today. Electrolytic cells are not spontaneous. Therefore, they need an energy source. State the number of moles of electrons lost when 4 moles of electrons are gained in this reaction. So remember the conservation of charge. Whatever you lose, you have to gain. So we gain 4 moles. We lose 4 moles, we lose 4 moles, we gain 4 moles. And then change in oxidation state, that happens for chlorine. Okay, so the chlorine goes from -1 to 0 because it's going it's like, if you look here, you can see that there's this, and it's going from -1 to 0 in this reaction. So yeah, using the graph determine the half-life of thorium-230. Okay, so this is 1 half-life, and I guess it's about what? So this is like 0.8 times 10 to the 5. Like, if you look here, I guess they're going up by 0, 0.2, 0.4, 0. Oh, might be 0.6 then. Wait, seriously? That's annoying. Wait. I think this one would be, like, very lenient with this kind of graph. So this is 1 and half. This is 0.5. So here's like 0.75 times 10 to the 5, I guess. I don't really. Okay. Fraction. 2 half-lives. Okay, so this is after 1. This is after 2. So you can say 25% or a quarter, or however else you want to express this quantity. Compare the penetrating power of a beta particle to alpha particle. So what happens is that since the beta is physically smaller, it has a greater penetrating power. So you would say the beta has a greater penetrating power than the alpha particle. Compare the nuclear equation. Oh. Yeah, I don't know. I don't know what the nuclear equation in my answer booklet is. Decay of U-238. Okay, I guess I can use table N. 238 has alpha decay. So this is alpha decay. Okay, I'm not sure if this is what you're supposed to do, because I don't want to pull up an answer booklet, but I think this should be right. So in terms of elements, why nuclear decay is considered a transmutation. Well, it's a transmutation because you're going from one element to the other. So this reaction, almost done. It's okay. Considered a transmutation because the uranium is changing into thorium. So yeah, I love how predictable the Regents exam is. It always ends with nuclear chem. Okay, so hopefully that was helpful. Good luck and have fun studying for the Regents exam.